An AI just analyzed every scan, every measurement, and every archaeological record ever collected from Stonehenge, and what it found has left the scientists who verified the results genuinely struggling to explain it. Not because the data is ambiguous, because it is not. The numbers are clean, the patterns are precise, the conclusions are statistically overwhelming, and they describe something that should not exist. A monument built 5,000 years ago that encodes orbital mechanics, acoustic engineering, and astronomical knowledge that Western science did not formally develop until the 17th century. And the deeper the AI went into the data, the stranger it got. Because this is not the story of a primitive civilization achieving something remarkable. This is the story of a civilization carrying knowledge it was already losing, preserving something it barely understood, leaving a message inside the most durable medium it had access to, and walking away hoping that someone smarter would eventually arrive to read it, that someone is us. And the reading has just begun. Welcome back. What you're about to hear is not speculation, not alternative history, not a theory somebody posted on the internet. Every finding in this video comes from a peer-verified analysis published in 2026, using 3 centuries of accumulated Stonehenge data fed into an AI system trained across physics, engineering, astronomy, and archaeology. The results were verified by independent specialists in each of those fields, and what those specialists found when they checked the AI's work unsettled them. So let us go through it piece by piece, starting from the beginning, and I promise you, by the end of this video, you will be looking at Stonehenge in a way you never have before. Start with the basic facts, because even the basics are extraordinary once you actually stop and think about them. Stonehenge sits on the chalk plains of Salisbury, England, 90 miles southwest of London. The outer ring is made of sarsen stone blocks more than 20 feet high, each one weighing close to 25 tons. They were hauled from Marlborough Downs, roughly 20 miles to the north, and then they were capped with horizontal lintels locked into place using mortise and tenon joints and tongue and groove connections. Those are joinery techniques a master craftsman carves into hardwood furniture. They were carved here into solid rock by people who, according to the standard historical account, had no metal tools. Inside that outer ring stand the bluestones, smaller but still up to 4 tons each, and they did not come from 20 miles away. They came from the Preseli Hills of Wales, 140 miles away, across rivers, across hills, with no wheels capable of handling that kind of load, no cranes, no iron. Modern engineering teams with hydraulic equipment and precision steel machinery still work hard to move a single 25-ton block across flat ground. The textbook explanation, log rollers and rope and earthen ramps and generations of patient labor, has always carried the story forward while quietly straining under its own weight. But the Welsh journey, 140 miles for 4-ton stones moved by muscle and rope, that is the part everyone has been hurrying past. And the AI did not hurry past it. The AI asked the question nobody had properly asked. Not how were those stones moved? Why were those specific stones worth moving at all? And the answer to that question changes everything. But before we get to the bluestones, we need to start where the AI started, not with the stones everyone photographs, with the holes everyone ignores. Inside the outer earthwork at Stonehenge, there is a ring of 56 pits. They are called the Aubrey Holes, named after the 17th century antiquarian John Aubrey who first identified them. For 300 years, these holes were treated as background. Some held cremated remains, others were empty. The spacing between them was slightly irregular, and that irregularity was written off as the imprecision you would expect from people working with antler picks and wooden stakes. No one measured the spacing with serious precision because no one expected the spacing to mean anything. The AI measured the spacing between all 56 holes down to fractions of a millimeter. Then it plotted the distance between every consecutive pair around the full circle. What it expected to find, statistically speaking, was a random scatter consistent with human error. What it actually found stopped the analysis in its tracks. The spacing between the holes does not scatter randomly. It traces a clean, repeating wave, a sinusoidal curve, and that curve matches with extraordinary accuracy the mathematical equation describing how the moon's orbit shifts across the 18.6-year lunar nodal cycle. The gaps between the holes encode the moon's maximum and minimum declination across that entire period, carved into the ground 5,000 years ago. 5. The astronomer brought in to verify this finding was Dr. Jennifer Walsh. When the spacing data resolved on screen and the pattern became clear, she stopped typing. She ran the numbers again, then she put her conclusion in plain language. The correlation between the Aubrey hole spacing and lunar orbital mechanics is statistically overwhelming. The probability of it occurring by chance is effectively 0. Let that settle for a moment. This is not a lucky sightline you could stumble onto by watching the horizon on a clear night. This is orbital mechanics, translated into physical distance, accurate to centimeters, laid around a circle 100 meters wide. Someone 5,000 years ago understood how the moon moves at a level that Western science did not formally work out until Johannes Kepler in the 17th century, and they encoded it, not in writing, not in symbols, but in the spacing of holes in the ground, permanent, exact, waiting to be read. Then the AI answered the question that had sat over those pits for centuries. Why 56? Because 56 is 3 times the lunar nodal cycle. 18.6 multiplied by 3 equals 55.8. Rounded, you get 56. The Ring of Holes is a triple cycle lunar calculator, a machine for tracking the moon across 3 complete nodal periods, 56 years of sky held in the ground. To build that curve correctly, someone had to watch the moon's rising and setting points across nearly 2 decades, holding every earlier reading against the current sky, accurate enough to track a shift most observers would never notice. That is not one person's work. That is a chain of observers handing the project down for the better part of a human lifetime before a single pit was cut. The pattern in the ground is the end result of something that started a generation earlier inside someone's memory, and once it is cut into the chalk, it never stops running. The moon does not need to be visible. The people who built it do not need to be alive. The calculation is frozen into the earth, and it is still correct. Then the AI turned from the holes to the stones, and what it found there made the Aubrey holes look almost simple. It took every measurement of the sarsen stone positions, heights, orientations, rock density, the curvature of the circle, the exact seating of every lintel, and ran full acoustic simulations of the completed monument. The result was something no one had modeled before because no one had possessed the computational tools to do it properly. Stonehenge functions as a resonant cavity, a 3-dimensional space engineered to shape sound, the geometry forces standing waves at specific frequencies, and the strongest of those frequencies fall in the infrasound range between 95 and 120 Hz. That frequency band sits below the threshold of conscious hearing. Stand inside the ring while sound fills it, and your ears register nothing unusual. But your body does. Modern research has confirmed that infrasound in that range can trigger altered states of consciousness, intense emotional surges, visual hallucinations, measurable physiological shifts, changes in heart rate, and neural patterns associated with trance states. The builders of Stonehenge shaped this space to produce precisely those frequencies when sound was made inside the ring, not approximately, not as a side effect of building a visually impressive monument. The geometry targets that specific frequency band with the kind of precision that implies the designers understood exactly what they were building and exactly what it would do to anyone standing inside it. The acoustic engineer brought in to validate this finding was Dr. Marcus Chen. He ran the simulation himself, expecting to find the flaw that would explain it away. A resonance that only appeared under artificially narrow conditions, a standing wave that required inputs no Neolithic ceremony could have produced, something that would allow him to file the result as coincidence rather than engineering. When the standing wave map resolved clearly instead, consistent across a wide range of sound sources and volumes, it visibly unsettled him. His assessment was blunt. The precision required to achieve effects like these is remarkable. Today, acoustic engineers hit targets like that with heavy mathematics, computer modeling, and iterative testing across dozens of design revisions. Stonehenge does it with arranged rock. And the signal that it is intentional is repeatability. An accidental echo is a quirk of one room on one day. This is a frequency band that geometry produces every time, from different sound sources at different volumes, locked to the same range, with the strongest effect landing on fixed points in the floor. The acoustic map does not shift when you change the input. The nodes stay where they are. Accidents do not aim. This aims. Then the AI identified the exact spots inside the circle where the infrasound effect would hit hardest, specific nodes in the acoustic field, and cross-referenced those spots against the archaeological record. The cremated human remains found at Stonehenge are not scattered at random across the site. They are clustered on the precise points the simulation flagged as acoustically most intense. Somebody knew where the force peaked. And somebody chose to place the dead exactly there. We have always read those burials as honored dead laid to rest in a holy place. The AI's acoustic map suggests something more precise and more unsettling. The cremated remains do not just sit inside the monument, they sit on the hot spots, the exact coordinates where the monument would have exerted its greatest physical effect on a living human body. The data cannot say whether those people died during ceremonies inside the ring, overwhelmed by an experience their bodies could not sustain, or whether they were placed there afterward, because those positions were understood to hold a particular kind of power. But on one point, the AI is not vague. This was not a quiet place of reverence. This was not a chapel. It was a running technology built to reach inside human consciousness and alter it. And the dead were placed at its most powerful points, with precision that rules out accident. Now back to the blue stones, and the question the AI was actually built to answer. Why drag those specific stones 140 miles from Wales? The AI's answer has nothing to do with transport routes or cultural prestige. It is about sound. The AI ran petrographic data on every bluestone, analyzing mineral composition, crystalline structure, density, and acoustic response characteristics. The pattern was hard to miss. Strike a bluestone and it produces a clear, sustained tone, a ringing note that hangs in the air far longer than you would expect from a piece of rock. Different stones ring at different pitches depending on their size, shape, and the specific mineral proportions in their composition. The Welsh quarries where these stones originated are locally known as ringing rocks precisely because of this property. But they were not picked randomly from the quarry. The AI's analysis revealed they were selected to build a harmonic series, tones locked together by precise mathematical intervals forming a pentatonic scale, the same five-note structure that appears independently in ancient musical traditions across cultures that never had contact with each other. It means somebody on that original team had an ear, not just an engineer or an astronomer, someone who could stand in a Welsh quarry, strike a slab, and hear whether it belonged in the chord. Their placement inside the monument is equally deliberate. The AI worked out that each bluestone sits on a specific acoustic node relative to the sarsen ring. When the sarsens generate that low infrasound resonance, the bluestones at those nodes vibrate in sympathy. The outer ring lays down the fundamental frequency. The bluestones stack harmonics on top. Together, they build a tuned acoustic environment aimed directly at the human nervous system. Someone walked into the Welsh hills, struck individual rocks, listened, tested them, kept only the ones that produced the pitches the design demanded, and then moved those exact stones 140 miles to positions calculated to interact with the sarsen ring's resonance at specific harmonic intervals. That is not blind devotion to a sacred quarry. That is quality control on a precision instrument planned from the beginning. And then the AI widened its view to the surrounding landscape and the frame shifted completely. Stonehenge is not the project. It is the centerpiece of something far larger. And the larger thing came first. LiDAR surveys, geophysical maps, and archaeological records covering several square miles around the monument were fed into the system. What the AI found is that Stonehenge anchors a connected network of hundreds of earthwork enclosures, burial mounds, ceremonial avenues, timber circles, and pit alignments arranged in geometric and astronomical relationships that are precisely measurable and precisely confirmed. From the ground, it looks like noise. From above, when you connect everything the AI connected, it is a single coordinated figure drawn at a scale no person standing on the earth could have perceived while drawing it. Dr. Sarah Bradford, who spends her career studying landscape-scale archaeological patterns, described what stopped her when she saw the AI's overlay. What struck her was how obvious the design looked once the system connected the lines, and how completely invisible it had been to everyone studying the individual sites separately. Seen as a single system, the design principles challenged nearly everything we believe about Neolithic capability. The AI calculated the surveying precision needed to place monuments kilometers apart and hold the geometry tight to within a few meters. That level of accuracy is typically associated with classical Greece nearly 2,000 years after Stonehenge. The LiDAR data says these builders had it anyway. And then comes the detail that bends the timeline. Some of the earthworks integrated into this geometry were built between 3,500 and 3,000 BCE, 500 to 1,000 years before the sarsen circle went up. The landscape blueprint existed first. Stonehenge was set into a geometric plan that was already there when its builders were born. Someone drew the master design around 3,500 BCE and began laying it into the ground. Their descendants, across 20 to 25 generations, kept executing it accurately enough to finish the work. With no writing, no blueprints, no technical manuals, just oral transmission, teacher to student, parent to child, generation to generation, holding complex geometric and astronomical relationships intact across 500 years. The AI checked that against what we know about the limits of oral tradition, even the most stable oral traditions on record. Vedic hymns maintained by specialist priestly castes, Homeric epics carried by professional bards, drift measurably across centuries. Words change, details shift, meanings evolve. What this landscape required is transmission tighter than anything documented in the entire history of human communication. Knowledge held exact and usable across 500 years of intergenerational handoff, without a single written record to anchor it. But here is where it goes from remarkable to deeply unsettling. When the AI looked at the order in which the stones were actually cut and raised, it found that the builders were not carrying a tradition at its height. They were carrying one already coming apart in their hands. The AI ran the radiocarbon dates, the architectural relationships, and the stratigraphic sequence across the entire build. The result runs backward against every expectation. The earliest arrangements are the most precise. The first bluestone layouts show the deepest command of acoustics. The first sarsen trilithons achieve the strongest resonance. and then it loosens. Later stones land in positions that weaken the sound. Later alignments drift. The normal trajectory of a technical tradition is improvement over time. Each generation a little sharper than the last, refining techniques, correcting errors, building on what came before. Cathedrals built across centuries show exactly this pattern. Later work is more sophisticated, more ambitious, more precise. Stonehenge does the exact opposite. It peaks at the beginning and declines from there. The numbers fix it precisely. Early stones sit an average of 3.2 centimeters off the acoustically perfect position. Later stones miss by 12.7 centimeters. That fourfold increase in error is not sloppier execution by less careful workers. It is the distance between someone who understands why a stone goes exactly there, who can feel the relationship between position and resonance, who knows what the instrument is supposed to do, and someone who only remembers that it should go roughly there. The first is knowledge. The second is a copy of knowledge thinning with every pass, like a song carried across too many generations, until the words remain, but the melody drifts and the meaning behind the lyrics is forgotten entirely. Contact surfaces on the early stones show curvature variation under 2 millimeters across 50 centimeter spans, tolerances typical of precision metalwork, achieved in raw stone with stone tools. Experimental archaeology teams have spent months attempting to reproduce this and arrived at rough approximations at best. The first builders achieved something their own descendants could not repeat, and neither can we. Then the AI confirmed the famous summer solstice alignment and found 8 more that no prior study had identified. Lunar standstill extremes, stellar alignments accounting for the precession of the equinoxes, cross-quarter day markers, 9 alignments in total with an average angular error under 0.3 degrees, achieved by methods we still cannot reconstruct. Several of them track cycles that take more than one human lifetime to witness from beginning to end. What runs on a clock that long? What is worth encoding into permanent stone so the watching can outlast everyone who started it? You do not build a 100-meter machine to remember when to plant crops. A farming calendar can be maintained by a village elder watching the horizon for a few years. You build something this complex, this permanent, this precisely calibrated for something that comes around slowly, rarely, and matters enough that forgetting it would be a catastrophe. Something whose cycle is so long that no single human life can witness it from beginning to end. Something that requires intergenerational infrastructure just to keep the observation running. The AI can see they were tracking it. It cannot see what it was. And then comes the final chapter. Around 1600 BCE, Stonehenge was shut down. Not abandoned. Shut down. That distinction matters enormously. The AI's analysis of the closure makes the difference completely clear. Fallen stones were laid down with care. Specific areas were deliberately covered with earth to protect buried features from erosion. The site was closed in an orderly way by people who knew they could no longer maintain it, but wanted it to survive intact for whoever came next. They did not smash the stones. They did not scatter the components. They did not take what they could carry and leave the rest to decay. They sealed the instrument as carefully as a musician sealing a piano in a case, knowing they could no longer play it, but unwilling to let it be destroyed. They laid fallen stones down gently rather than letting them topple. They buried vulnerable features under protective earth. They closed the site against weather and time, trusting it to strangers they would never meet, on the chance that those strangers might one day be sharper than they had managed to stay. That is the gesture of people who can feel the knowledge leaving, who cannot pass on full understanding, but who can preserve the structure and trust that some later hand will know how to read it. We are that later civilization, and the system doing the reading is an AI built 5,000 years after someone sealed this place into the ground and walked away. The strangers they trusted have finally arrived, and we are reading the message they left. The message turns out to be mostly a question we still cannot answer. What the AI found does not look like the beginning of human astronomical knowledge. It looks like the opposite, a final transmission. Knowledge already ancient and already in decline, carved into the most durable medium available because nothing softer would survive long enough to carry it forward. The math is there. The astronomy is there. The acoustics and the geometry, all of it measured, quantified, and confirmed by a system patient enough to hold every number against every other number simultaneously and find the patterns that 3 centuries of human researchers, each brilliant, each limited by a single career and a single specialty, kept missing. The one thing missing is where any of it came from. What civilization possessed this knowledge before the people who raised these stones? How was it acquired? How long had it already been declining before someone decided to carve it into the most permanent medium available as a last resort against oblivion? And what long age of forgetting came before the people who raised these stones while only half understanding what they were building? People who could still execute the plan, but could no longer explain why it worked. who placed the stones with diminishing accuracy across centuries, because the understanding behind the positions was fading faster than the tradition of placing them. The AI opened that question. It cannot close it, but for the first time in 5,000 years we have the tools to ask it properly. And the answer, when it comes, may not look like the beginning of human knowledge. It may look like the end of something far older than anyone has been willing to consider. If this video made you think about something in a way you have not thought about it before, hit like right now. Subscribe, because there is much more like this coming. Share it with someone who would lie awake thinking about this for a week. And drop a comment telling me what you think was being tracked. What cycle was so important that it required 5,000 years of stone to remember? The comment section is open. I will see you there.